Hello everyone. Good morning, good afternoon, good evening to all. Dear authors and invited guests, welcome to technical session 2B. My name is Jay Lalwani. I am the moderator of the session. And if you have any query or any update, please send me in chat box. On behalf of Global Knowledge Foundation, it is my great pleasure to welcome you to the 6th International Conference on Information Communication Technology for Intelligent System through Zoom. Further, as you all are aware, we have facing a new normal situation while overcoming the pandemic. As the conference is shifted to a hybrid mode, we hope you will enjoy the knowledgeable and interactive sessions. We also hope to have you at the future physical version of the conference. Also, there is a special note for presenters. It will be given 7 to 8 minutes for presentation and 2 minutes for question and answer. On 7 minutes, I will raise a gentle reminder. And I request while the presentation is going on, other participants kindly muted. There is also a request to the participant that you will all stay connected us till closing marks. Just before we get started, I would like to introduce you all to the chair for this session, Professor Anuma Jain. And Professor Anuma Jain is working as associate professor and the head department of computer science and IT, IIS, located in Jaipur, India. An academician for the last 21 years, he has actively contributed in teaching industry and R&D, knowing that teaching is the best form of giving knowledge back to society. Research interests include soft computing, computational studies, and software engineering. She is the author of 9 books and has published a number of papers at the national as well international level. She's a reviewer for many journals and leading book houses. Also, she is associated with different academic bodies in diverse capacities, including being the convener for the board, studies member of academic council, curriculum committees, etc. Thank you, madam. Welcome.
Thank you, Jay. Thank you for giving such a good introduction. So I welcome all the participants who are going to present today to the conference. So can we start with the session?
Yes, madam.
So is everybody ready?
Yes, madam.
Okay, so the first participant is Anand Sesh Katti. The paper is Pipeline for Pre-Processing of Audio Data.
Yeah. Hi. Just give me a second. I'll just share my screen. Am I audible?
Yes, you are.
Okay. Good afternoon, everyone. My name is Anand Katti, and the paper that I'll be presenting today is Pipeline for Pre-Processing of Audio Data. These will be the contents of the paper, which will be discussed in the presentation. So the introduction, every machine learning approach or deep learning approach have different procedures to be carried out. That includes collecting data, analyzing it, and pre-processing it, and then using it for the model implementation, and then calculating the results. In all the paper, the project that I was working, I am working on is for sentiment analysis and emotion recognition. So this is just a part of that entire project. So the pre-processing technique is only being discussed in this paper. For the papers that I refer to, from the published papers that I refer to, what I got to know or the observation that I had was that when it comes to pre-processing or data collection, the content specified in those papers was limited to one line to one paragraph at the most. So that was one of the main motivation that led me to prepare a paper for the pre-processing of data. So we'll be preparing, so the paper is discussing about pre-processing for audio data. Now, why audio data is because emotion recognition, be it, or sentiment analysis, be it, in CRMs, we basically are trying to capture feedbacks in terms of emails or textual data. But nowadays, it's more often becoming a trend to have audio data as well, wherein the company is calling out customers and have recording their sessions or one-on-one sessions, audio calls. So that is why we thought of, and also that textual data was the research in textual data is done vastly, and there's less content on audio. So that's why we have considered audio data here. So in this paper, we have proposed a pipeline for audio pre-processing. Now, how when to use this is also been will be discussed. Now, basically, what happens is that at the start of the implementation of pre-processing techniques, what I faced problem was that we had to do it manually one after the other. So, in order to automate that and to not do it one after the other, or to do it in batch process, we had
Just a
proposed
minute. Are you moving your slides or you are on the first slide only?
is first slide itself. I'll be moving
Okay,
now.
okay.
Okay. So that's why we have implemented or proposed the pipeline here. So the proposed works consist of 5 different classes in this. That includes from loading of audio files to padding, extracting log, and normalizing the audio files and saving. So we'll discuss this in depth in the further slides. Now, this is the basic architecture that we have in the proposed system. So we have a one common pre-processing pipeline class, which is calling out different classes that are going to perform those specific tasks here. So from that is loading and padding and so on. Okay, so let's take a look at first class, that is loading and padding class. So these are two different. So first we'll go with the loading one. So this class is responsible for loading each and every data, audio data file present in the folder. So this is not, so when we are executing this entire program, so it is not going to take in one audio at a time. It is going to take all the audio files that are present in the folder in batch. So we have considered a .wav file here instead of .mp3 because this was a better way that I thought were to work on with. So a few parameters we have used is sample rate, duration, and mono here. Now mono is basically the channel being used. So that is a single channel is being used instead of stereo or dual channel. And the duration here includes consists of the length of the audio files. So different files have different audio length duration. So that has been considered here. And the sample rate we have considered to be a particular thing, the particular hertz, that is 60 hertz here. So the next is padding here. Now, this is responsible for applying padding to an array of audio data. So when we talk about audio data, it's basically an analog signal. But when we want to implement or pre-process it, we have to convert it to a digital format. That's why we are considering it after conversion. We're considering it into an array format with having different values of that particular audio file. That is why we have said array here. So the parameters used here are an array and a missing value. There are two parameters different here. The array, as I just mentioned right now, and the missing value is what it means is that there are different. So there might be 100 audio files or 1,000 audio files, and every audio file might have different durations so one might have 10 seconds of duration, one might have 15 seconds of duration. So in order to to make it work better or efficiently, what we do is that we are trying to match a single particular length for all the audio. So in case there is the maximum length of an audio is 15 seconds and there are the rest all the audios are less than that, then we try to match that 15 seconds of thing. So in order to do that, what we do is the missing value comes in picture here. So those missing values are then replaced with a zero or which is called as zero padding here. The results will be showed at the end of the slide. So we'll have a look at that also. The next one is the log spectrogram here. So it's responsible to extract log spectrogram. It's basically time series or signal, and it's also a representation in terms of visual audio files in terms of visualization. So we are using a short-time Fourier transform here to extract that with the parameters as frame size and hop length. Now hop length is basically it's a non-intersecting portion in a window length. Okay, so every frame in this frame size or whatever we have, there are different in a frame size we have multiple frames. So every frame is called as frequency bin here. So the shape of the STFT, what we get at the end is a two-dimensional array. So the first dimension is 1 plus frame size divided by 2. Now, basically, this is one dimension, and the next is the total number of frames is the second dimension here. So let's, for example, take a standardized frame size of 1024 here. So when we add it, when we replace the value in the formula or the shape here, then it becomes 1025 by 2, which is 512.5. But considering decimal value there it becomes a little difficult to work with. So we try to round figure it to 513 here. The next is normalize and saver class. Let's talk about normalization here. It's basically to apply a minimum and maximum of the particular array. Now, what it means that is that when we talk about an array of that audio file or of a particular audio file, there are varying values from 0 to 9. So what we want to do is we are trying to downscale that to a scale of 0 to 1. To do that, we use
Dear
normalize.
presenter, sorry to interrupt, you have last 2 minutes.
Yeah, thank you. So the formula is basically is shown in the diagram here. So we are using a dot operator and the inbuilt minimum and max value, max method from Python and calculating the normalization here. And the last is saver file, saver class. Now, what this does is that it is responsible for storing all the data outputs or results of the previous existing classes. So for example, log spectrogram, we are storing it in terms of a NumPy array. So that extension has been mentioned in this saver and also the destination of the file, as well as the normalization results, which is in terms of a pickle file, is also been specified into the saver and also the destination for that particular folder results to be stored at. So the results where you can see is the log spectrogram, and as well as zero padding has been you can take this as an example. The first starting values are actually the log spectrogram, and to match the length of the duration, we are adding zero values, so zero padding at the end. So basically, by default, this right padding is being used instead of left padding. So that is why the values of zeros are at the end here, so right side. The conclusion is that we proposed a pipeline here, which basically helps us automate the entire process without manually doing every process for every individual audio files one after the other. It's also a component-based approach. So in case at all, so for us, the requirements were only these many classes. So we only implemented these many classes for the project. But for one's own requirement, they can add in any number of different methods and approaches as per their needs, and still make it work. Pipeline can also help speed up the process here. Thank you. Questions? Any questions?
Anand, can you
Yes,
just go on the title of your slide?
Yeah, you can.
Okay, so this is basically pipeline for pre-processing of audio data. Just move to the next slide. Next. Where you are talking about those format of the files.
Format.
Yes.
Oh, yeah. Right.
Can you just tell me why you are just using .wav?
Because a .wav file can it can capture a lot of data. So in case of a .mp3 file, when you talk about a .mp3 file, is that it's a shorter version and there are less data that can be captured from an audio file. So in terms of size, it is also less in size. So that is only because of the reason is that it is not of high quality, and the audio might be not clear. So a few of the data, when capturing the features or extracting the features, or some of the features extraction is done, that time will be a lot of data will be lost. That's why we are using .wav file here.
Okay. And what are your future goals after doing the pre-processing for pipelining of audio data? What
Okay,
will you do?
so this was one of the steps in my entire project. So this being one which is already completed, and we are already moved on to the next step and also implemented that part. Probably we'll be coming up with a paper for that also. But the main idea was to actually analyze sentiment and emotion of audio files.
Okay. So how will what are your plans? How will you do it?
Right now, what I have done is that we have worked directly on the audio files for sentiment analysis. But in terms of when you say sentimental analysis, it's not enough when we talk about only audio files, because the content of the audio, whatever the spoken content is there, we cannot analyze that by directly using the audio. So, but still we have prepared a model and got some results about, say, 68% on an average, but that is not enough. So we are still figuring it out and exploring more ways where we can improve the accuracy by considering more aspects also.
Okay. Okay. Thank you, Anand.
Thanks so much.
Yeah. So we move on to next presenter, Febin Antony. He'll be presenting on classification of Alzheimer's disease MRI images with VGG16 and VGG19. Are you ready, Febin?
Yes, ma'am. Yes, ma'am. Just 1 second.
Okay. Please start.
Am I audible? Hello.
Yes, you are audible.
Yeah, thank you. So my name is Febin Anthony. I'm a research scholar from Christ University, Bangalore. I will start with the presentation. My topic is classification of Alzheimer's disease MRI images with VGG16 and VGG19 model. So this is my agenda for today. I will start with the problem statement, introduction, ADNI, Alzheimer's disease neuroimaging initiative, data acquisition, dataset analysis, and I will explain about the dataset. Proposed methodology for the classification of Alzheimer's disease, skull stripping and augmentation, remove the non-trainable images. I will explain the VGG16 model as well as the 19 model, then results. So this is my problem statement. To develop an efficient model to categorize Alzheimer's disease based on MRI scans. Introduction. You all know, like when it comes to age 65 or above, most of our parents or grandparents, there might some damage in the brain. So that might be Alzheimer's disease or dementia. So we need to analyze those things. Like dementia is a disorder that has to be noticed and cleared at its early stage itself. So we need to analyze what all things are happening in our brain. So the central nervous system is covered at its periphery by two important constituents such as gray matter and white matter. So our brain contains two matters like gray matter and white matter. So if a person is affected by Alzheimer's disease, the brain will shrink. That's the gray matter will shrink and the white matter will enlarge. So that's the main cause of Alzheimer's disease. So we need to analyze that. The use of deep learning techniques with different model architectures was used for the early detection of Alzheimer's disease using PET and MRI scans. So we can use PET images as well as MRI images. In this paper, I'm using MRI scans. Alzheimer's Disease Neuroimaging Initiative. It is a platform where we can get the data set. It's not a normal platform, it's the raw data set. We will get the raw data set from ADNI platform. So the resources mainly provided data sets of 5 different types, such as MRI images, PET images, clinical data, biospecimen, and the genetic data. The data is collected and authenticated to keep its consistency and quality. The ADNA focuses its study participants across 3 different states of Alzheimer's. Like there are 3 different states of the disease, our brain disease. One is cognitively normal. That is there's a minute chance of Alzheimer's disease, and the mild cognitive impairment, that is the middle stage, and the Alzheimer's disease, the final stage. The Alzheimer's disease is a non-curable disease. Data acquisition. In this paper, I am taking a T1 weighted MRI dataset where different scanners are used, like Siemens, GE, and Philips scanners are used to collect digital imaging and communications in medicine. That is in the DICOM format. So all the data in Alzheimer's disease are in the DICOM format. Neuroimaging core of ADNA is used to develop the final multimodal imaging plans for the MRI and PET acquisition and to maintain data quality and scan consistency. So I had analyzed all these machines separately, Siemens, GE, and Philips scanners separately. There is a minute variation in the accuracy. I think Siemens is getting more accuracy, but just a minute changes in the accuracy, some 0.2%. So in this research, I had taken a general data set. That means the data are acquired from Siemens, GE, as well as Philips scanners. So these are the data set I had used. Three classes are there: cognitively normal, mild cognitive impairment, and Alzheimer's disease. Subjects, 25 patients are there from each classes. Age groups, 65. Trainable images, 200 each, and testing images, 60 each. So total of 260 images per class. So here, these are the three combinations I had tried with VGG16 as well as VGG19 architecture. One is cognitively normal versus mild cognitive impairment. The model shows whether a patient is cognitively normal stage or at the beginning of the mild cognitive impairment. Same as Alzheimer's disease versus CN and MCA versus AD. So this is the proposed model. I will start with the image acquisition that I had explained. Image pre-processing that includes skull stripping, image segmentation. Model building with VGG16 and VGG19. Image classification, CNN classification I had used here. Model evaluation, that is the accuracy, recall, and precision that I will explain in the next slides. So this is the first step with the data set. First one is the skull stripping. So we don't need to use the entire brain images. We need to remove the skull part because we don't need to analyze the skull part. That won't change. So only the brain regions will change. So I need to eliminate the skull part. That is the skull stripping. I will take the original image, then the biggest content, like the gray matter. I will take only the gray matter with RGB coloring. Find the extreme points with the coloring part, and then the crop images. I will crop all the skull images here. The data augmentation to increase the data set with different angles and different views. Non-trainable images, like we'll get, these are the data sets which we cannot analyze in our project. So we need to eliminate those data sets, like the blurred one or the very light one. So we need to eliminate all those data sets. So for this thing, I had code for it. Like we need to eliminate this non-trainable data for getting a good accuracy. So this is the VGG16. VGG16 is a convolutional neural network model with a 16 deep layers. So this is used for the medical classification. VGG16 replaces the large kernel size filters with 3x3 filters. That's it. And VGG16 is a fully connected network with a size of 533 MB. So this is the VGG16 model with feature extraction and classification. But in the classification part, I had used the CNN part. That means the purely CNN part, not the VGG16 part. Same as VGG19. VGG19 with the 17 layers, including 19 trainable deep layers. This can classify into 100 object categories. VGG16 is trained over millions of diverse images with classification. So this is a pre-trained network, VGG19. VGG16 is not a pre-trained network. And this is the VGG19 model. Here also I had used the CNN classification. So these are the results, like VGG16 is getting almost 82% accuracy in MCA versus Alzheimer's disease. That is the mild one. A mild stage versus the Alzheimer's disease stage. It's getting an accuracy of 80%, and the CN versus MCA, the accuracy is 82%. And CN versus Alzheimer's disease, the accuracy is 81%. Same as the VGG19 model, I'm getting the accuracy CN versus MCA is 90%, MCA versus Alzheimer's disease is 87%, and CN versus Alzheimer's disease is 86%. So this is the conclusion. Here, we had analyzed over the VGG16 and VGG19. It shows the accuracy rates of VGG16 with an average of 81% and VGG19 with an average of 84%. So it's better to use VGG19 model in the brain analysis part. So these are the references I had used. That's it. Thank you. Any questions?
Yes, my question is, have you studied other models other than VGG16 and VGG19?
Yeah, RustNet. I'm working on RustNet and Inception V3 now. So
Okay.
even that are getting good results. So I might be submitting a paper to same ICTIS in the next session. So I'm
Okay.
writing a paper on it now.
Okay. Okay.
So
And secondly, what is the activation function that you have applied
which activation function?
for this model of yours?
A purely CNN function, purely CNN model.
Okay, it's a purely CNN.
Yeah. Even this VG16 and VGG19 are a part of CNN, but I had used VG16 and 19 in the feature extraction part. So feature selection is fully pure CNN.
Okay. So feature selection is through CNN, and for future extraction is
VG16 and 19.
okay.
Yeah.
Now, are you a PhD scholar?
Yeah, I'm a PhD scholar.
Now, what are your future plans? How will you go about it?
Like now I'm comparing ResNet 50 and Inception V3 with MRI images and the PET scan. This work I had done 1 year ago. This was my starting phase. So this work I had done
Okay.
1 year ago. Now I'm working on ResNet 50 and Inception V3. Both are getting good accuracy, maybe more than this one. I'm frankly saying more than this one. I'm getting accuracy around 92 to 94% accuracy in Inception V3. So I'm working on it now.
Okay. So, what are you planning to contribute in this research?
In the society.
Yeah.
Yeah, we will get a good model here. So by the end of my PhD, I might be done with almost 7 to 8 models, including
Okay.
VG16, 19, Inception V3, ResNet, all that. 7 to 8 models. So I'm
Okay,
planning to create a multimodal biomedical imaging here.
Okay.
Yeah.
All the best. Thank
Thank
you.
you, ma'am. Yeah, thank you, ma'am.
Okay. So the next speaker in line is Divakar. He will be presenting on comparative study of CNN-based multi-disease detection models through X-ray images. Are you there, Divakar?
Yes, ma'am. Am I audible?
Yes, you can start.
My screen is visible, ma'am. Hello. Hello.
Yes, you can start.
Good afternoon, all. My name is Divakar. I'm research scholar at Baba Saheb Bhimrao Ambedkar University. Lucknow.
Divakar, you can start your presentation in slideshow mode.
Ma'am, am I audible?
Yes, you are audible.
My slide is visible or not, ma'am?
Slide is visible, but you can run your slideshow. The
Okay.
PowerPoint is just open. Just run your slides.
Okay, ma'am. So my topic is comparative study of CNN-based multi-disease detection model through X-ray images. Let's come to the introduction part. In recent years,
But
medical
I'm
imaging-
asking Divakar,
Yeah.
can you just go to the slideshow mode? Just select your slideshow menu. Go to the slideshow menu. Slideshow. At the top in the menu, Can you just go on the slideshow one? Just move your mouse, insert data design and onto slideshow.
I'm not
Can
showing
you
anything.
select slideshow?
Press Control F5.
Yeah, just press Control F5, right?
Control F5. Nothing is happening here.
Can you see the icons at the bottom right corner? The one with the notes, comments, etc. at the bottom right corner before Zoom. Just the icon before the Zoom. Right hand side.
Let me share
corner.
again.
Share your entire screen so that we can see your presentation in the presentation mode, not in the PPT.
And now
You just right click on your slide. Just right click on your slide. Right click. Can you see some slide? Press F5 if you can. So that your presentation starts off.
Press F5 on keyboard.
Function key F5. Yes, now
Yes.
it's done. You can start now.
okay, ma'am. Ma'am, my topic is comparative study of CNN-based multi-disease detection model through X-ray images. So let's come to the introduction part. In recent years, medical imaging play a significant role in different clinical applications such as diagnosing, early detection, monitoring, and many more. But due to the shortage of radiologists or doctors, it is like difficult and a time-consuming task. So that is why artificial intelligence can address this problem by using machine learning approach. So by using machine learning approach, we can develop a model and we can train model by giving data. And then after, when we are giving new data, then machine can able to take decision and prediction on based on past data. So objective here. So my objective here, as we know that deep learning approaches are proving to be effective and offering more accurate disease detection. However, still we have significant hurdles in medical imaging. So in my research work, I studied on deep learning based framework such as ResNet 15, exception, VG 16 and 19. And I do implemented using transfer learning approach for multi-disease detection and still images which can able to diagnose the multi-disease. I'm using transfer learning approach because we do not have proper resources to train any model from scratch. That is why I'm using transfer learning approach. Lots of research work has been done in this area, and a few of them are listed below here. Like one paper which is classifying pneumonia using ResNet 15, 50, VG16 and 19 and giving accuracy around 84%, 93 around and 93%. And other papers are like COVID detection, ResNet 15, VG19 and inception version 3. And this is giving accuracy 94%, 98% and 97%. And other papers are like COVID detection by using X-ray images mentioned here. So in my paper, I experimented 4 deep neural network models, ResNet 15, exception and VGG16, VGG19, using transfer learning approach with ImageNet dataset to detect 4 types of classes: COVID-19, normal image, pneumonia, and tuberculosis. So here we are using transfer learning approach to train our model, and we got accuracy for all the models. For ResNet 50, I got 81.38%. For exception, I got 89.72%. For VGG16, I got 98.33%. And for VGG19, I got 98.05%. Here I'm showing general architecture of CNN model using transfer learning. fully connected layers. So in last fully connected layers, I'm training the model, and other layers are freezed. And with the freeze layer, I'm using weights from ImageNet. So then after we are like using classifier layer. In classifier layer, we are mentioning our 4 classes for COVID, normal images, and pneumonia and tuberculosis. For this paper, I'm using data set from Kaggle, and for each class, I'm using 700 images. For COVID, 700, normal images 700, pneumonia 700, and tuberculosis as well 700 images. Here my general architecture of multi-class classification model. I took all the images, all the data, and then after I pre-process the data, it means like resizing the data that I took 224 cross 224 cross data, and we divided the data in 2 parts, trained set and test set. Trained set contain 85% of images, it means around 595 images, and test set contain 105 images, 15% of images. Then again, I categorize all the data in different folders. And then after I train our model with train set 85% of images. And then after I tested our model by 15% of images, and we got accuracy, F1 score, precision, recall, confusion matrix. For this experiment, I used Google Colab K80 T4 GPU. And for all, and I use Adam optimizer with the learning rate 0.001, with the epochs 30, and size I took 224 cross 224 pixels. My experimental results showing here. In VGG16 case, I took a COVID image and I got 99.95% accuracy. And for other normal pneumonia and tuberculosis, 0 point something that I got. So it's giving correct result. And again here in VGG19, I took tuberculosis image and I got 99.45% case of tuberculosis and other 0 point something. Here in ResNet 50, I took tuberculosis image and I got 38% in case of tuberculosis and other COVID 30%, normal 24%, pneumonia 7%. So here 38% is bigger. So that is why it's showing like tuberculosis. And again in here in exception I used I took a normal image and I got 100% accuracy in case of normal. And for other 6 point tuberculosis 6.9, pneumonia 1 point something, and COVID 4 point something. And next slide, I'm showing training and validation, accuracy and loss. So here showing for all the models what kind of accuracy we are getting. So through the graph, I'm explaining here. I'm showing here each and everything. And here in confusion matrix displays the number of images classified correctly or incorrectly. As per the confusion matrix, we can see like VGG16 and VGG19 models performing well with the higher training and validation performance. In the case of ResNet 50, shows few conflicts between COVID and tuberculosis. We can see here in the output image. F1 score and precision recall, we are calculated, and we got that for all the models, VG16, 19, ResNet and exception, 97%, 97%, 84, and 87% respectively. Conclusion. So by using deep learning method for all 4 popular models, VG16, 19, ResNet 15, I got accuracy 98.33, 98.05, 81.38%, and 89.72%. So by using transfer learning approach. And for other models, here we can see like VGG 16 and 19 giving best result, best accuracy. But in case of exception and ResNet, we are not getting that much accuracy. 90% accuracy that we are getting. We can improve other models like ResNet and ExceptionNet by fine tuning or by giving more data for training purpose. Then after maybe we'll get a more accuracy in case of exception and ResNet. But with only one experiment, we cannot say like any model is performing well or not. So we can train our model with more data, or by using fine tuning, we can get more accuracy for any kind of data, any kind of model. So every model depends on number of factors like data set, size, number of epochs, fine tuning techniques, optimization techniques, and many more. Here references. Thank you.
Okay. Devakar, can you tell me what is this transfer learning model?
Ma'am, transfer learning means already we have trained weights. I'm using here ImageNet weight, which is already trained on 14 millions of images. So in transfer learning approach, if we have a similar kind of task, so in that case, we can use that data, that weights in our model, and we can get we can use that weights in our model, and then we not need to train any model from scratch, because we cannot train any model scratch without GPU configured systems. So that is why I'm using transfer learning approach.
Okay. And like, what is your contribution in this particular field?
My contribution is here. I experimented on 4 models, and I get to know like VGG 16 and 19 performing well. So in real time application, we can use
that means nobody has basically experimented on these 4 models.
Ma'am, obviously, ma'am, experimented. Even I mentioned here for references, those are using only two classes.
Okay.
I'm using 4 classes. In 4 classes, I'm getting at 98% accuracy. So I believe in real-time application for clinical applications, we can use VG 16 and 19, because if I'm using a single model for any kind of disease detection, that will not work for real time. The reason behind, if I'm using, suppose any patient is infected by tuberculosis, and we are testing that person by any machine which can detect COVID. So in that case, that machine will give normal response. So that will not work. But if we have a multiple disease detection model, so that model can able to detect like person is infected by COVID or tuberculosis or pneumonia.
So what combination of models do you suggest for diagnosing multi-disease?
Ma'am, I'm suggesting like 16 or 19. Anyone can use. And
no, so should we go only for one model or combination of models? Because like you said, that a person having tuberculosis might not be detected properly when we are testing for COVID. So what I'm asking is, will single model suffice to these multi-disease detection?
No, ma'am, no, not possible, ma'am. For single model can detect only one disease. So if person is infected by tuberculosis, then that model will detect only COVID. And in that case, that model shows like patient is normal.
Let's say we don't know what disease the patient has, and we have to give our predictions based on the picture. Then which model will you suggest?
Ma'am, basically this model, if person like similar kind of symptoms, I'm talking about similar kind of symptoms like COVID, in case of COVID, tuberculosis and pneumonia, person having shortness of breathing and fever, weakness. So in that case, if we have multiple disease detection model, then only we can able to identify like person is infected by which kind of disease.
Okay.
Yeah.
Thank you.
Thank you, ma'am. Thank you so much.
So we move on to next participant, that Asmita S. Deshmukh. Her paper is entitled Students' Employability Concern for Colleges and Universities.
Yes, sir.
Okay, so Ashmita, you can start.
My topic is students' employability concern for colleges and universities. I am a research scholar under HVPM CUET Amravati. My presentation outline is introduction, literature review, research gaps, objectives, proposed methodology, implementation, conclusion, references. Implementation is only partially done. So, introduction, the educational system is the backbone. We are all aware of this, and it helps us for the social progress. Now, initially, it was only data mining that we used to work with when we had a good set of data, and we tried to extract the important features from it. For this education particularly, we now have educational data mining, which is going to help us predict the students placements, as well as the learning analytics can be done under educational data mining. So it is a method of applying the data mining methodologies on a large number of students, which will be definitely helping the students not only for placements, but also for the teaching learning process. The goals of this EDM are many others. Say for example, we can predict the students' future learning behavior in terms of which subjects they can opt for, what their interest is, and accordingly. Employment of the students is a main concern, as I told, for the colleges, for the universities, and that is my main concern. So these, I had divided my paper into different types, that is the papers under big data analytics tools methods, which I had studied for trying to make a decision about what will be the best thing that I can use for my proposed work. So it is big data analytics. I have a few papers, then educational data mining, clustering based EDM techniques, and EDM using other methods. So this is what I have gone through. These are the various the papers having these various things covered, and then I try to find out what are the research gaps in it, so that I am able to put up my work. So as I told, educational data mining and then learning analytics, this it generalizes the current movement in higher education. So though the educational sector uses several techniques for extracting the useful information to the students to undertake the learning process, it is needed to develop a student performance assessment model, which will really help us with what our motive is. So everyone, let it be a college or let it be a university, even in my colleges, as the teachers are concern is, how do we have a majority of the students placed in their final year itself. So reviews carried out in the past are based on certain data mining techniques such as statistics, visualization, clustering, classification, pattern mining. This model should not only identify the model that I wish to design, should not only identify the contributing factors for performance, but should also assist the students to improve their performance to the next stage with the assistance from the faculties at the placement. By this, what I mean is that we need not wait for the students to reach their final year and then start working on their skills, but we can start this process from their second year onwards itself. So in EDM, data mining and machine learning are assumed as the subfields that are highly significant to show the increments and advancements in academics and the teaching process. So although a lot of work is existing on this educational data mining. So this is what I found. Predictive analysis can be conducted using machine learning techniques to train the model and predict what will happen in the future. For example, what can be the academic performance of the student. Most of the studies that I had gone through and the papers that I have noted down in the previous slides were related to the foreign universities, or probably only focusing on the academic grades. What I wish to do in my work is not only focusing on the academic grades, but as the current market scenario is, even other skills matter, and along with the academic grades, this companies or the placements are concerned about what other skills the students possess. So the data sets that were existing as per the book data set, then information to be collected as a data set should have attributes as per our requirement. And that is why I told that although the studies have many papers, many places it has been going on, but what is found is that there are some attributes that we have identified and which are not a part of the research that was ongoing or that is being done. So jobs are only provided to the skilled people, and that is the reason I was talking about other skills. So many institutions, colleges and universities conduct recruitments every year, but all the students do not get placed. That is the alarming situation. And
Ma'am, can you just move to your own work?
okay, is it?
Yeah,
fine?
we can talk about this object.
Yeah. Okay. So this is my objective. So what are the main findings in EDM as I have discussed just now? What are the students' performance measures from the point of view of both the practical skills and the academic performance? How do we find them out? And what are the explainable machine learning methods used to predict the students' performance? This is a proposed work, which is just the beginning of my work. So data collection, which I have started with in terms of what I have done is for my college students, I have shared since it was a pandemic. So last year I could do it. The Google Forms I had shared to get the information from the students. Not only related to what their semester grades were, but along with it, what are their skills in terms of computer engineering students, what is the language they find good among the different languages that they had already studied in the syllabus, or even otherwise by doing some course. Then what are the if they have attended any project competitions, if they were a part of any courses online or offline that they have done for the certifications. So this is what I have collected in the data collection activity. Pre-processing, so all the data that is collected or that was collected will not be the clean data that can be immediately processed, but there can be some missing fields, that can be some other things that require the pre-processing. So that is the next phase. Then we have data integration, that is the data that is collected from the various sources. By this, what I mean is, I have collected the data from the students in some terms of say 10 to 20 fields. I also have data in the department related to the individual students. So all this data, or for the office data as well. So this can be integrated, and it can be placed in a place on which I can carry on my analysis. So the next phase is the analysis and the prediction, then knowledge extraction, and the results which can be shown visually, which will definitely not only be helping the placement cells, but we can also have a judgment prior about what can be done for the students. Say for example, after going through all this, I understand that there are a few students who are good in this, few more students who are good in some other
Dear
skill.
presenter, sorry
Yes.
to interrupt, you have last 2 minutes.
Okay. So this is only the initial part, ma'am, that I have finished. So the students can register in the form that I have shared, and then the training application form. So the intent of my system is going to be, which I have only partially started doing. So it is going to I think this proposed system will help the institutions analyze the students' performance during the pre-placement phases. As I have told, we can start up with this activity in the second year itself by collecting the information from the students. Then we can move on to making groups of the students who belong to a particular their interests are same. So the students who would like to make up their career in Java, who would like to make up their career in web designing, so accordingly we can conduct the tests. For why I'm talking about this as a pre-placement phases, we can conduct the test for these students. We can try to find out where they stand, and we can help them by by providing them not only the lectures, but by providing them the help from the expert faculties that exist in the college itself for that particular subject. So as during this analysis, along with academic performance, the technical skill set of the student will also be tested, which can turn and it will be helping the students. So this can also provide details about the students' expertise to help the companies know them better and thereby eliminate unnecessary rounds for the capable students. So if after the
Okay,
analysis,
Ashmita, I'm interrupting in between.
yes,
Can you just tell me, you have created an interface. What are your future plans? Have you started studying the machine learning models for prediction?
yes, ma'am. But when I have gone through this papers, machine learning algorithms, there were many machine learning algorithms that have already worked on it. So my basically the work have reached the part where I have decided about the attributes that were not done priorly. So as I have told, even the mother tongue of the students matters, because whether you are a good communicator, whether you are able to communicate in English, whether you are able to share your technical knowledge. So what is the student's mother tongue, in which language he has taken the education, about the soft skills also. So all this information I have tried to gather in terms of the attributes from which state he belongs to or which place he belongs to, so that even the geographic location may matter, because when I see the students in Mumbai and when we compare students to some remote place, then there is a gap or there is a difference.
Definitely, definitely. There has to be some gap. So you have to take the features accordingly, select your features accordingly.
Yes, ma'am. After that,
Okay.
even machine learning has been done to quite an extent by the major in the major papers. So what I was thinking is, although I have not gone into the depth, I can have some hybrid approach or model used, which will be
Right.
combining machine learning and deep learning.
Right.
Yeah, yeah.
Okay. All the best, Ashmita.
Thank you, ma'am.
Yes. Okay. So the next participant is Neha Helawat. Her paper is clipped RBM and DBN based mechanism for optimal classification of brain cancer.
Yeah, good afternoon, ma'am. I'm audible?
Yes, you are.
Okay, let me share.
You can start. Yeah.
Yeah, ma'am, yeah, I'm starting. Yeah, ma'am, my PPT is visible?
Yes, your PPT is visible. You can start.
Okay. Okay, good afternoon to one and all. I'm Neha Alawat. I'm a research scholar at SRM ISD NCR campus. My paper ID is 117. My paper title is Clipped RBM and DBN based mechanism for optimal classification of brain cancer. These are the content I'm presenting here today. First of all, I start with my abstract. So in past few years, many articles have witnessed a significant increase in medical cases related to brain tumor. And all these articles make brain tumor its 10th most common form of tumor, which is affecting children and adults in a large scale. And in healthcare, big data analytics has attracted great attention among the research community, and healthcare records are in very healthcare records is enormous challenging, not only by its volume, but also the different categories of data sets. So here, the main aim of this learning is to construct a structure or is to construct a model that may assist doctor in tumor resolution and classification. Here I'm working on MR images by the suggested algorithm, that is clipped RBM tumor detection algorithm. Here basically I train my RBM layer through clipped activation technique. I'm working on MR images Okay, first of all, I introduced about big data and deep learning because I'm working on big data and deep learning. Then I'm going my literature survey. So big data is a collection of data that is huge in volume, large scale information management also. And we analyze here technologies that exceeded the capability of traditional data processing technology. Basically, big data is classified under 5 V's. So I am here explaining one by one. First one is volume. So big data itself is related to a size which is enormous or which is very amount of data which is created every second, right? Then the second V is variety. Variety is because we are handling very amount of data which is created every second. So obviously it having many varieties of data. Now the third V is velocity. Velocity is the speed at which data is created. Then the next V is veracity. Veracity means if because we are working on many amount of data, so data may be in data, maybe some messiness also there or some trustworthiness or uncertainty also there. So it comes under veracity. Now the last V is value. So what value actually we are extracted from data, right? So this is the introduction of big data. Now deep learning, as we know that machine learning is a supervised or unsupervised learning. So I'm working here with deep learning because deep learning can work well on unlabeled data, and I'm working also in big data. So big data is a handle many large amount of data which is in unlabeled format. So I applying deep learning for analyzing big data. Obviously it provide efficient performance because I'm clubbing here unlabeled format also and unsupervised learning also. Now this is ma'am, I have to explain a literature survey also. Yeah, I'm audible, ma'am.
Yes, you are audible.
So I
Let's
have to
move.
explain or I have to skip?
No, no, no,
literature
no, no.
survey?
Please don't explain
okay,
this. You
okay,
can move
okay.
on to your work.
Okay, ma'am. Okay. So this is my proposed architecture. Here, as I told, I am working on unsupervised or unlabeled data. So I am basically using here DBN, that is Deep Belief Network. It is an powerful generative model that is uses for deep architecture. Here, as you can see, multiple stack of RBM, right? So RBM is restricted Boltzmann machine. So first of all, I trained that RBM one by one. In first slide, I told that I used clipped RBM. So here, RBM I trained by using clipping process. Then like that, I trained every layer. So this is the whole network can be this is the whole network trained by a greedy layer wise learning algorithm from bottom to the top. So DBN is divided basically into 2 stages. As you can see in this figure, these are the 2 stages, pre-training and fine-tuning. In pre-train phase, we are working on unsupervised learning, and in fine-tune phase, we are working on supervised learning. So like this, I have my input layer, then I trained my RBM, then hidden layer coming, then at last I got my output. So this is the proposed architecture. In pre-training phase, what I am doing unsupervised layer by layer greedy method to obtain network, which optimize the weight parameters by training stacked RBM one by one. And here I'm using contrastive divergence method also. Basically, it involves 3 steps: forward pass and backward pass. When I trained my RBM, I am using 2 passes. One is forward, one is backward. Okay. So in under contrastive divergence, basically 2 phases are there. One is positive phase and the other one is negative phase. So in positive phase, what I am doing, I am training again RBM from input layer to hidden layer. Then in negative phase, again I am going from reconstruct the training set of the visible unit with the help of similar technique like positive phase. So these are the 2 phases under CD I am using. Then at last I am going for fine tuning phase. So basically in fine tuning phase, what I am doing, I am using back propagation and I'm modifying my weight parameters, right? And update all associated weights. Then I will repeat that steps of updating the weight till I get the required threshold value. So like this, I trained my all the layers using clipped approach. So this is my proposed architecture. And these are my performance analysis. Basically, I'm using accuracy, specificity, and sensitivity and F-score. These are all our confusion metrics where I'm using to compare different state arts methods. Now, this is the conclusion. The main pretension of my model is to determine the brain tumor from MR images. And here I'm using the clipped RBM approach. Why I am using the clipped RBM approach? Because it is removing the, when I am working on the many layers, so vanishing and exploding gradient problem are there. So by removing these vanishing problem, I'm using here that clipped method, which is clipped my boundary value, right? And then I trained my RBM hidden layer properly, that using that clipping concept, which really helped to reduce the problem of exploding gradient. Here I'm using ReLU activation function with clipping ReLU. Okay, I'm not using here simply normal ReLU activation function. I'm using here clipping ReLU function. So basically I'm clipping here my gradient, right? So it increase the excess of weights, and that exploding gradient problem is creating instability in my network. So I'm handling that instability using that clipping approach. Okay, so my proposed architecture is showing better outcomes as I shown in my performance analysis. So in future, I'm planning to evaluate how to upgrade my model and test it with different cancer database also on real-time application. These are my references, which I go
Okay,
through.
Neha.
Yeah, ma'am.
So this, can you just move to your conclusion slide?
Yeah, ma'am.
Yeah. This clipped RBM and DBN based brain tumor detection algorithm is being proposed by you,
Yeah, ma'am.
or people have already used this
No,
combination?
no one use this combination. RBM and DBN is already existing approach. Here,
Of course.
I am doing
Yes.
on activation area. I'm working on activation area. Here, I'm using clipped RBM. I am not using
Yes.
normal RBM, right?
No, that I can see in your slide, but
Yeah,
has
yeah.
anyone used?
No.
My question was that.
No, ma'am, no, ma'am, no, ma'am. Till now, I didn't see in any paper clipped approach they are using.
Okay.
Yeah.
Very
So
well
my work.
presented.
So it is my
Yeah.
work, ma'am.
Nani, your work is clear. You presented it well. Thank you.
Okay. Any questions, ma'am?
That was it. You have already explained your conclusion and everything well. Can you just move to your result performance analysis slide?
Yeah, ma'am.
I think, can you change the layout of your graph? I think that will give you a more better picture of your work.
Okay, ma'am. Sure, ma'am. Sure.
I think this is not giving the emphasis that has to be shown.
Okay,
Right?
ma'am. Okay. I have to upload somewhere, ma'am, this PPT or something?
No. That is for you as a suggestion.
Okay, ma'am. Okay. Thank you, ma'am.
Right?
Thank you. Okay. Anything else, ma'am?
No, that's it. Thank you.
Okay. Okay. Thank you, ma'am.
Okay, over to next presenter.
I'm leaving, ma'am. Okay.
Yeah. Anshita Malvya,
Yes, ma'am.
detecting deception news in social media using supervised machine learning techniques.
Yes, ma'am.
Yeah, please start.
Ma'am, is my screen visible?
Yes, it's visible.
Okay, thank you. Good afternoon. I am Anshita Malvi, and I am here to present my paper titled Detecting Deceptive News in Social Media Using Supervised Machine Learning Techniques. The contents of my presentation are introduction, literature survey, proposed work, conclusion, and references. Firstly, let's start with introduction. As we have seen that our society has witnessed numerous incidents concerning fake news. Social media has played a very significant role in its contribution. We have seen that people with the notorious mindset often are the generators and the spreaders of such incidents. And these mischievous people, what they do, they spread the fake news without even realizing the effect it has on the naive people. People believe on these fake news and they start behaving accordingly. Fake news appeal to our emotions and it plays with our feelings and it can make us angry, happy, or scared. Also, fake news, we can say it as deceptive news, can lead to hatred or anger towards a specific person. Nowadays, people easily befool each other using social media as a tool to spread the fake news. As we have seen in this
Anshita,
yes,
Anshita, I'm interrupting in between. Can
Yes.
you please skip the introduction part and move to your main work? Yeah.
yes, ma'am. So this is the literature survey. I'm skipping it also.
Yes.
So what I have done,
Yeah,
I
you
have
can just brief about what you are going to do. That would be
ye-
better. Yes.
yes, ma'am. So there are various ways by which we can detect the fake news. So what I have done is that the method used is that identification of deceptive news by proposing the machine learning based models which are implemented in Python. Different machine learning algorithms like logistic regression, multinomial naive Bayes, passive aggressive classifier, and multinomial classifier with hyperparameters are used. And for model evaluation, different vectorization techniques have been used. As in this algorithm, we can see that we have taken the input as the fake news data from social media, and output is the accuracy of the models. I will explain this algorithm with the help of this flowchart. Firstly, what we'll do, we'll enter the news data sets. Then we'll pre-process the data set using different type of vectorization techniques like TF-IDF vectorizer, count vectorizer, and hashing vectorizer. Then what we'll do, we'll split our data set into train and test data sets, design and train our models, then test the models and output the accuracy of different models. If we have more data sets, we can repeat the same previous steps. After that, we'll analyze the accuracy of the models. So the machine learning techniques used are logistic regression, multinomial naive Bayes, passive aggressive classifier, multinomial classifier with hyperparameter. So this table 1, this table shows the details of the data sets which I have taken. 4 data sets have been taken, their attributes have been shown, and the number of instances of the data sets and the size of the data set. The pre-processing technique have been done in this data set are, firstly, we have removed the stop words, then performed the tokenization, then vectorization using 3 different vectorization techniques. Designing of the model using these 4 algorithms. This table shows the comparison of accuracy of different data sets. So I can tell that about data set 1. So in data set 1, when we have applied the TF-IDF vectorization, we have pre-processed the data using TF-IDF vectorization, we have found that logistic regression, passive aggressive classifier gave the best result. And when we have pre-processed using count vectorization, we found that logistic regression gave the best result. Similarly, using hashing vectorizer for data set 1, when we pre-processed it, then we found that logistic regression gave the best result. Similarly, in this table, it can be shown for data set 2, data set 3, and data set 4. 4 data sets have been taken and all these steps have been done. This figure shows the accuracy report for data set 1 and in 2 different formats. Similarly, this figure shows the accuracy report for data set 2, data set 3. This shows the accuracy report for data set 4. Next, this table shows the accuracy report for TF-IDF vectorization, and next for count vectorization and hashing vectorization. This table shows the confusion matrix for data set 1 and which shows the true and predicted label, fake news, real news for TF-IDF vectorization. Next for count vectorization and hashing vectorization. Conclusions and future directions. So it has been found that for all the used data set in experiment, passive aggressive classifier gave the best result using TF-IDF vectorization. And further, it has been observed that all the models gave best performance using TF-IDF vectorizer in comparison to other vectorizers. And we have got 98.4 and 97.6% accuracy for passive aggressive classifier model and logistic regression model respectively. These are the elementary observations based on the 4 data sets, and to confirm the findings, more versatile data sets can be used. As future work, we can do more experiments by using more machine learning algorithms, pre-processing techniques, and data sets for building the efficient fake news detection system. And these are the references. Thank you.
Nicely presented, Anshita. I have a few suggestions related to your presentation first, and then I'll ask you a few questions.
Okay, ma'am.
Firstly, when you make your presentation, please, all of you, in fact, I should tell that about Febin also, if he's still here. When you make your presentation, just run it in presentation mode and see. Like your flowchart diagram, it was not at all clear to us in the presentation. The font size was very small.
Oh,
So
okay.
pay attention to such small trivial things in the presentation. It will make it more effective, right?
Okay, ma'am.
So the image should be clear enough and the font size should be visible. Okay,
ma'am.
Anshita,
Yes,
it's a
ma'am.
very simple question. You are an MTech student.
Yes,
How
ma'am.
would machine learning algorithms predict whether the news is fake or not? How?
Ma'am, machine learning algorithms, as we know that by training the machines, we could get the results. So they can be more efficient because we are
No,
training.
I'm not asking you how machine learning models will work. It's a very simple generic question. As a layman, if I'm asking you, how can machine learning algorithms predict the news to be fake? Can you tell me?
As we human, when we human beings used to see the news, we used to believe them, and we don't find any criteria to judge either it is real or fake. So with the help of machines, we can do by training them.
But in fact, for training them, we should know that this news is fake or it is true, isn't it?
Yes, ma'am. Yes, ma'am. So firstly, we will take a data set in which we knew in advance that the news is fake or not, and we will train our machine. When our machine would be trained.
Okay, but that has to be some area specific, isn't it? How
Yes,
can it judge all the news, isn't it?
Using different pre-processing techniques.
But will it always be successful?
It cannot be guaranteed, but yes, machine gives result.
But why do we rely so much on the machines all the
time?
Okay, Anshita, thank you very much. Let's
you.
move on to Krushit Upadhyay. His paper title is 4G Communication Radiation Effects on Propagation of Economically Important Crop of Eggplant.
Good afternoon, madam.
Good afternoon.
Am I audible?
Yes, yes, you are.
Okay, let me share my screen. The other participant here. Okay, so good afternoon, everyone. I'm going to present 4G communication radiation effects on propagation of an economically important crop of eggplant. I'm Krushit Upadhyay. I'm working as a professor at Charotar University of Science and Technology, Charusat, Changa, Anand, Gujarat. That's my presentation outline. Our introduction, literature review, experiments, method, business. The background concept was this way: that a lot of work has been done by far on the effect of electromagnetic waves on the human body, effect of electromagnetic waves on a living organism. But relatively, there is a lesser quantum of work presented in regard to the effect of electromagnetic waves on the plant. It is apparent that there is a sharp rise in the mobile communication subscribers across the globe. And this is to basically fulfill the communication traffic requirement, communication demand or commercial demand. So cell tower sites are regularly coming up, both in the area of agricultural land as well as the urban sites where human population is there. Now, what we have witnessed is farmers are permitting the installation of mobile towers in the agricultural land just for the sake of small financial motivation. And the problem is radio waves are non-ionizing radiation, which possesses a lot of low quantum energy, which does not govern the ionization of the atoms. And when this specific electromagnetic waves gets interacted with the living matter, they get absorbed by the living matter, and the energy transfer process takes place. So eventually, it creates the heat and it creates the thermal effect within the body. So this paper, this manuscript tries to address to the effect of physiological and biochemical analysis on what happens when we have electromagnetic wave being absorbed by the agriculture as well as the medically important plants. A very quick introduction, maybe for a minute. According to the ITU, there are at the moment somewhere around 6.4 billion active subscription, and this is yet 50% of the communication requirement, and this is supposed to be this is going to go up to 10 million active subscription. So we shall need a lot of communication towers. Now, this electromagnetic waves shall create heat-related issue. And as I said earlier, there is a huge research community which has by far addressed this issue, what happens when it gets mutated within the human or animal body. But there is also significant research which presents the electromagnetic wave on both fora as well. Right? Now, this electromagnetic wave exposure creates problems such as cancer, metabolic disorders, cardiovascular disease, so on and so forth, many reasons for the death. So, and we consume our energy primarily through the healthy diet, which are being affected by these electromagnetic waves. And what eventually happens is the stress which is being created by these electromagnetic waves gets converted into the oxidative stress. Okay. This is the literature review. I think I'll skip this literature review. But majority of this are converted, 3G and 4G effect has been analyzed in past. So let me focus on the experimental setup, what we did. The diagram A, we have RF signal generator, which was responsible for creation of 4G frequency at 2100 megahertz. So helical antenna was there, a transducer was there, which was emitting the electromagnetic waves. And that was imposed on the 2 type lines of A plans. And what you can see in diagram B is there is a transmitter setup of helical antenna, which is responsible for generating the 1800 megahertz electromagnetic waves. So there were, parallelly 2 A plans which were raised. One is within this laboratory with exposure, and the another which is a control plant which was raised in the controlled environment. The technical parameter of this experimental setup was we had the helical antenna in a range of somewhere around 14 to 15 dBi gain. The electric field which was available exactly at the plant was somewhere around 7 volt per meter, and the magnetic field which was measured to magnetic field meter around the plant was somewhere around 1.9 meters. This is the materials and method through which the physiological and biochemical analysis were done. So first thing, exposure treatment, where we have multiple 2 type plants. Control plants were kept separate. So 2 parallel plants were raised. One without exposure of 1800 megahertz frequency, another one with exposure of significant exposure of 1800 megahertz. Right. The physiology, seed germination rate was checked. Plant growth parameters were measured. Stress marker of H2O2 was done, and photosynthesis pigment analysis by means of chlorophyll A and chlorophyll B contains were done. And finally, both the results were compared for observing the effect. So this is the first result which was expected in terms of plant leaf parameters. So there were 3 primarily parameters as a part of physiological measurements were carried out. First was the longest leaf length variation. Second was the leaf area variation, and another one was leaf count. So as you can see, when we give the exposure to the plant, so there were multiple time durations. So initially starting from 0 hours, we had first result taken at 12 hours, 36, 48, so on and so forth, up to 96 hours. Now, what you can see is the leaf parameters of eggplant plants reveal a significant modulation, which has shown the reduction of leaf count by somewhere around 39%. Length of the longest leaf somewhere around 67%, and leaf area by somewhere around 75% upon the exposure of 96 hour compared to the unexposed leaf, as visible in the diagram. This table covers the exposure effect on the plant seed growth and its physiology on exposure of different hours. Initially, it was observed that the seed germination rate was enhanced for somewhere around 12 to 24 hours of exposure, which is considered as the positive effect of the radio waves. Then after, such effects was strongly restricted. The rate of germination then after reduced in the range of somewhere around 6 to 56% after 24 hours of exposure compared to the control. The plant growth parameters, wise plant height, root length, were similarly enhanced in case of 12 to 24 hours exposed seed. Then eventually it got deteriorated at the 96 hours of exposure. The plant height was also decreased as high as 62% between 36 hours to 96 hours of exposure, and root length was also decreased up to 58% compared to the unexposed plant. In addition to that, the fresh weight and dry weight of plants were deteriorated for the long-term exposure, and the relative water content of the plants, which is also very crucial for the plant health, got reduced up to 44.4% upon the exposure compared to the control. So, as a summary, as a part of this deterioration, at a very high rate was observed at a longer rate of somewhere around 96 hours. Now, you can imagine that if we have exposure of 96 hours for this, what happens when we have a continuous exposure of electromagnetic waves on this plant? It is going to have multiple hazardous effects on the plant physiology, and eventually we are going to consume it. So that's a risk factor. The next thing is biochemical analysis. So this biochemical analysis were taken up, and the chlorophyll content, chlorophyll A and chlorophyll B, was measured. You can see that respective decline was somewhere around 52%.
Dear presenters, please conclude the presentation.
Yeah, sure. So 52% and 37% was visible in chlorophyll A and chlorophyll B. The biochemical analysis as H2H2 content was also significantly changed up to 66% upon the exposure of 96. The conclusive remarks is the physiological parameters has shown that the electromagnetic wave effect is there on the plant system, and it is going to create a lot of hazardous effects. And this is the beginning of it. We are marching towards fifth generation communication and sixth generation communication. We can imagine this is going to get used. All right, and these are some selected references. Thank you for your time.
Okay, thank you, sir. I have no questions because this is a very hot topic and you have presented it well. We can move on to next candidate. I think this is a very good research sir has done, I think, and they can submit it to the, I think, agriculture or climate department for taking it up further for the society benefits.
Yes, yes.
Thank you, sir.
Thank you.
So the next presenter is B. Jerish, and the paper title is Users Nostrum Spot for Consulting and Prescribing Through Online. Online, isn't the title incomplete, Jerish? Is Jerish there?
Yes, ma'am.
Through online, I think there should be some one word more on your title.
Yeah, it's specifically we have made a slight change in that.
Okay.
It's to prescribing for rural areas. Yeah, my screen is visible. Hello.
Yes, screen is visible. Please start.
Yeah, this is what our title refers to, user milestone spot for consulting and prescribing for rural areas. In this, the main objective is to the people is duplicated to visit the expert while they are in a sick manner, or they are unable to move to the specific location in certain place. For that, they can visit the expert by booking the doctor who is available for the medic, or a doctor who is available for the calamitic reasons that is asked by the client. Our automation application will avail the specific specialties to synchronically explore the data, and they can also consult them through online whenever they need it. And the main intro is in the specific COVID-19 pandemic time, there are numerous nations declare the full lockdown. Therefore, the patients can't move to the live, or if they are going to the hospital, they can't meet any doctors who are unavailable at the certain time. For that, this application will make them major impact, and it will give the doctors availability status, and we can consult through online, or we can meet by direct by making an appointment. The economy of the world is descending because of the result of the lockdown. It will enhance the results. And at the point when COVID-19 was shown, it moves like a lockdown. In this, there is a crisis, like the specialists are is in danger state. They are unable to come to that specific location. In that case, we can refer any specialist nearby, or other specialists who are available in that time. We can also check the medicines availability in that COVID dread, and we can purchase the medicines which we have needed by getting it in the nearby locations or nearby rural hospitals. It will be very good enough to get medicines in that local area itself. It is another way of emergency treatment consulting also. It is made inside the actual of the home, or getting a through online is a security. And these are the papers which we have referred in that. The first author who is made a title, they have only focused on fixing the application through the agents, and they can be showing the job as mobile agent appointment system. While moving on to the second, they will show that the increasing doctor schedule, so the free times can be fixed and the doctor can be available. And then in the third title, we can see that the medical records is collected and stored in that electronic device, and the health records is personal for users in the specific hospitals. And while we are moving into the fourth, it is specifically denoted to the WHD, and it is personal monitoring, not it will be the other parts. And in fourth one, the medication systems is like a hardware device for the patients who is going to meet the doctors. The doctors are allowed to make a fingerprint system which will show their availability as intake timing. This is a hardware device which is not recognized by the most. And in the sixth one, if we make any visuals, the conversational and personalized styles will get to learn more things. And while we are moving into the seventh one, they have given a merits like a value of the patients and doctors, and they are also added the values of the hospitals to be more accessible, like healthcare with online booking and video conferencing of medicals. But they are lagging through that availability of the medicines and the doctors who are in time and who will be available to solve the specific problem as a specialist. And that the final one is the high graduate employee rate. They are is the opportunities will of the travels is the major merit in that. But the travel is not only the impact to get into the consultant. And while we are find us several gaps, like the existing applications where deals with only with the appointments and not other than that, we have moved with that medicine availabilities and doctor availability status, and we can prescribe through online or offline, whether it's need to be metered, or we can consult from here itself. We can choose anywhere we want. And there are some layouts to be maintained by manually, which is like storing the data of the doctors who's available in the hospital and the patients who is monitoring their records. All should be maintained by the manual person. And there is no futures like government and private hospitals are separately working. In this, we can combine every government and private hospitals through the green doctors who is available in the specific areas, and we can merge the government and private hospitals, which the data is huge. And there is no need of IoT device verification like fingerprint sensor, and we need not require any option to facility they need. And this is the architecture of our proposed system. We can start our application and we can give the username and password. We can select the appointment option. In that, we can select the hospital or a treatment category, like we can choose through online or offline, or we need to communicate with the doctor through Meet. Whatever we want as the category, we can choose it in the drop-down list box. And if the doctor is availability, we can check the doctor availability. If it is available, then the client will be selected to the hospitals, like private or public, whatever the hospitals they need, they can prefer as they need. And if it is no, they can suggest the option for another specialist who is available to the same problem. And if the client is selected the hospital, if it is a private hospital, there will be a payment option. If it is not, then it will directly move to the confirm booking page, and finally it gets over. In this, we can use the mobile application anywhere. We are carrying our mobile phone nowadays. Anywhere we go, we can use our mobile phones to book appointment wherever we are and whenever we need. And this, the appointment booking and medicine availability, is the major advantage, which is we can look anywhere in that mobile through Android Firebase. The Firebase will store every medicine availability status and booking status. And in this, our proposed architecture, we will specifically focus into village panchayat and government primary health care centers for checking doctor availability. There is 3 pages like admin, doctor, and patient login. Both private and government hospitals are included, and the options to consult through online or in person or home consultant. Appointment option and medicine availability within the rural areas will be updated every hour, and the expert list of appointment can be looked by our admin site. And in this, we have used the Android Studio to develop an application and SDK plugin. In this, the JDK6 is used in the creation of the application to make it manual. And we can use the Android 6.0 to install the packages and code in Android Studio. And we can prefer the languages like Java 8 and XML. The modules are admin, doctor, and patient. The admin module is used to add a hospital or timing, and we can add any doctors who are known to us, and we can maintain the appointment and medicine availability. We can also add the graph, which is denoting the report of a month or report of a week. And the doctor module is having the profile and appointment. He can also make his logout by his own. He can, in the appointment section, he can approve the appointment, which is requested by the client or the patients who is in that profile. He can update, and that patient, he also has a profile that will be denoting that the summary of his health reports and whatever the things he have. The appointment is enabling him to make appointment to the specific doctor. This is the remote of the implementation module 1. In this, we can see the admin module. Here we can add hospital timing, add a doctor or appointment. And in it is for a doctor, and this is for patients. And our result is the UI will be easy and effective to interact with rural area users. It will mainly focusing on providing the rural area peoples to fetch the database and get the medicine availability status. By knowing the medicine availability status, he or she can use the database to attain the medicine from where we can want and when it will be available. The primary healthcare centers along with private hospitals is a new one to make that our entire part to be good. And as of now, we have collected the primary healthcare centers for details for to several districts, and we are not moving further. And our conclusion is the suggested web is very interactive to make a framework. Like we can carry our Android Studio or Android application everywhere we want, and it will be useful to make a expansion of the system administrator and specialist to meet through online. And there may be a assist that the specialist is enlisting for that waiting people. Then there will be a assist for the specialist. He can consult through whatever the patient is lagging with that health or any other things. We can also play out our undertakings, and there will be more upcoming features will be added with this client subsection. It will enhance the client to report whatever they are facing and issues or whatever the problems they are attaining, and it may be fixed in the future on upcoming works. The intention of the data is respective schedule. The future works can be which will be extend this study to use other districts will be included zone as well as the village panchayat hospitals, and using the different future for appointment. Furthermore, to provide the medicine availability and towards our application to be the one and only medicine preference in online. These are the reference which is undergone by us.
Thank you.
Yeah, thank you.
It's a very good project.
Yeah.
And tell me one thing. Already there are many applications available for the same, isn't it?
Yeah, there are applications available for the specific hospitals or specific areas. There is not a combined future, and in our we can make a appointment category which is required by us. That may be online or in person, or we can meet through Google or whatever we want. We can fix by our own, and at the same time we can check the medicine availability in village panchayat and local hospitals itself. It will enhance us to make, if we are in need of any medicines in emergency, we need not to search where the medicine will be available. We just use our application to get where it will be available and when it will be available. Then we can move there directly to get it.
Okay, thank
Yeah.
you.
Thank you.
So the next paper is from Praful B. Bafna, a novel heist based topic modeling approach for Marathi language. Yeah, over to you, Praful.
It's not allowing me. Yeah. Are you able to see my screen?
Yes, we are able to see it. You can start.
This research is related with regional language, Indian regional language. Let me explain within 1 minute what is the need of this research. More than 75% information is present in the form of text. And if you want to analyze this text, or if you want to have unhidden, if you want to disclose hidden information of this text, then you need to have several further pre-processing steps for that. So if you are able to manage this information, then it will support different applications. And generally this work is popular in English language. Indian regional languages are very low resource language, and that's why we have chosen this language. It will help the researchers who are actually doing some PhD work in this Indian regional language. We have applied topic modeling on the documents which are present in Marathi language. So topic modeling is a statistical model which allows you to identify topics of the corpus or document set. So given the corpus, it is unsupervised learning. So given the corpus, it will find out based on which topics that corpus is being designed. It is based on this topic modeling is based on frequency of words. So we can say that as the resource care language are present, their accuracy, the application's accuracy, any application you take, even in English document management also, there is problem of accuracy of that particular application. So naturally for Indian regional languages also, for text analysis, the accuracy is the problem. Why accuracy is the problem? Because generally this these applications or these techniques do not consider synset or do not consider meaning of the word while classifying or while clustering the documents. What we have done here is we have incorporated the meaning of the word, and that's why we have got a better accuracy than the existing techniques. To get better accuracy, what we have done is we have constructed vector space model for Marathi and high synset based vector space model for Marathi. So because of these two models, we have got better accuracy which considers the meaning of that particular word, which are important in the process of clustering or classification. So As I'm saying that right from pre-processing, there are important aspects of for any document management or for any application. So these are pre-processing steps right from tokenization to high sensor. So you can see here space is used as delimiter and different words are being tokenized. Then lematizations are formed. Lematization is nothing but the original words which are there in that corpus. So for example, if in English, if we consider running, then run will be its unique lemma. So instead of having redundant forms of run, that is run, ran, running, we will have original one word that is run, which will reduce our dimensions. And then the same meaning words or the synonyms and meronyms and hypernyms, which are differently related with each other, will be tied together as high sensate. These are different types of vectorization techniques. So I have shown one example where this shows the words and this shows their TF-IDF rate, that is term frequency, image document frequency rate for these different words. Now, if you see here, this matrix is designed by us, which groups the similar words, and it contributes to the dimension reduction along with frequency increasing. So if you see here, the frequency of these two words is being added along with dimension reduction. Based on the frequency that we have got, this document matrix, that is document term matrix, is being considered for total more than 1200 documents. And this is termed as high sensor based vector space model for Marathi. For topic modeling, for its evaluation, coherence constant is being used. And these are coherence constant for high sensor based vector space model. And you can see here that the coherence constant is maximum for 3 number of topics. This is something which is done for a different number of topics using VSMM, that is vector space model for Marathi. So both of these models are derived by us only. So the first version was VSMM and the second version was high sensor vector space model for Marathi, that is HVSM. Now let's see that which 3 topics are being came out from this HSVMM. So there were topic 1, topic 2, and topic 3. So these were the topics which were derived by using HSVMM. And these are the words which are representing those topics. Now let's see the topics which are retrieved from VSMM. So these are 3 topics. These are 4 topics which are retrieved by VSMM. And these are the words which are retrieved in those topics. This is one of the sample example where we can see that the beta constant, which was retrieved by HSVMM for the words or for the features which were derived or which were used by HSVMM. So the features and their beta constants are being represented in this particular graph. So you can see here actual beta constant values for a particular topic. This is the hierarchical document clustering, which was applied to have topic-wise clusters, that which documents are falling in one cluster, that has been found out using hierarchical clustering. And you can see the result of hierarchical clustering. So the similar documents are there in one cluster. Now you can see that how entropy and purity for VSMM and HSVMM are compared. So here is entropy by VSMM, HSVMM, VSMM purity, and HSVMM purity. So you can see that entropy and purity comparison for both VSMM and HSVMM. These techniques, as I have said earlier, are used to incorporate semantic relationships. LDA is used for that. Coherence constant is used for evaluation of LDA. Entropy and purity is used to evaluate clustering. Maximum purity is good clustering, and minimum entropy. So maximum purity and minimum entropy represents good clustering. And then we have seen that the coherence score was maximum for 3 topics for VSMM and 4 topics for HSVMM. And then hierarchical clustering was applied for these many text stories. And then we have checked entropy and purity for varied data sets. That's all from my side. Thank you so much.
Yes, ma'am. Okay, so what are your future plans related to this project?
Now we have started actually working on different languages. That is the first thing. Second thing, we are planning to actually disclose one of the languages, which is Braj. And if you see, for Braj language, no study has been, no single research paper has been published. Now I am in the process of drilling for Braj language.
You're planning to do away, or you planning to take a branch language?
Braj. I'm planning to implement the document clustering technique on Braj language.
Okay, okay. That's a good idea.
So if you search on net, there is no research done on Braj language.
Okay. This is somewhat near to Marathi?
No. You need domain expertise to understand Braj language. It's near to Ahmedabad, if you know that language.
So first you have to learn it, right?
Yeah, correct. So literature is available to learn, because right from stop words, you need to know the details of that language.
Okay. That's a great work. Thank you, ma'am.
Thanks so much.
Okay, so we move to next presenter. Again, I think Prafulla ji has to present a novel Marathi speech-based question and answer chatbot for the education.
Yes. So I'll share that screen. Able to see the screen?
Yes, you can start.
Okay, thanks. So my second research paper is again on Marathi language, but the application is different. It's chatbot, and the difference between the previous application and this application is here we are using supervised learning. So we are having a data set with us, and this data set is related to the speech-based input. So user will talk in Marathi language. The user's voice will be recognized, and that will be translated. And this translation will be done using Google API. And then this NLTK library will be used to process the translated text that is from Marathi to English. Then NLP techniques, that is pre-processing tokenization, will be carried out. And then naive Bayes classifier algorithm is implemented. And then chatbox application has questions as input, and it is expected to give proper answer. So the answer with the highest probability will be displayed through the chat box. And then answer will be fetched, and the best answer will be provided. This is the research methodology. Here you can see that the input question, it's translated English question, and from which domain that question is. So as this chatbot is related with the education domain, you can see that this particular word, this particular sentence is entered, which is based on education domain. The people can enter the sentence or enter the questions which is not from education domain too. So this is a generalized question which is being entered. And again, one of the sample questions in the education domain. Now, instead of having frequency of the words which I have done in my previous paper. Here I have found a frequency of the class. The use of this frequency is whenever the user enters the question, to which class that question belongs to, that will be found out using the frequency of the class. Here you can see the visualization of words using word cloud, where you can see that this particular word has more significance. So the questions which were asked by the user were having these words. So most commonly asked questions words are represented by this word cloud. This is document term matrix, which is input to naive by classifier. This is the binary matrix, and for each question, what are the number of words which are present or absent, that has been represented in document term matrix. Here is the comparison of probabilities for the word and the particular class. So for example, this particular word is present in this particular class because it is having highest probability, which is calculated by naive Bayes algorithm. So these words and their representative class based on their probabilities. Here is confusion matrix, which talks about the input class and the predicted class, what was the actual class and what was the predicted class. So you can see their misclassification error in politics type of question. Then the next is how the keywords are being used for matching algorithms. So if you enter the question here, then the answers will be there, which will be found out using the similarity matrix, cosine similarity matrix. And the keywords which are used for cosine similarity matrix are presented over. These are sample questions and their answers using string similarity algorithm, where the question was exactly present in the dataset. When the question is not exactly present in the dataset, at that time, when we can't use string similarity algorithm, we need to use TF, ITF and cosine similarity algorithm, where it will talk about the maximum similarity and the probability of that particular class. There were total 1,553 words for the model training. With 66% accuracy, we have retrieved the result. We have used naive Bayes classifier for multi-class prediction. Just now I have demonstrated this to education class or education domain, but this could be used in CRM domain, where live chatbot in different languages is the need of an era. Our future work will be focusing on context-based understanding of Marathi language, where we can use WordNet and same meaning words can be handled using word sense disambiguation and deep neural net. Thank you so much. That's all from my side.
Okay, I have a question.
Yeah.
Prafulaji, did you make this data set on your own?
No. We have taken it from different websites.
No, but the structure of the data set would have been created by you?
No, actually, for chatbot, whatever questions are there, those questions are ready-madely available.
Questions and answers are available, but this particular data set, did you get a consolidated data set existing in Marathi and English conversion?
No, for Braj language, you don't have any data set. You need to clear that.
No, I'm talking about because you are presenting on Marathi language, right?
Yeah. So yeah. So for Marathi language, multiple data sets are available comparatively. Like for English language, multiple data sets are available in numerous. For Marathi language, though it's low resource care language, some data sets are available which are made available by researchers in this decade only. Like these are not very traditional data sets like our 20 News or Reuters data set, which are traditionally used by English language researchers. These are low resource scarce language, but still these are available.
Okay. So even the converted question data is there in the data set.
Yes, yes, yes.
Okay. That's great. Thank you.
Yeah.
Thank you, ma'am.
Thanks.
We are done with the presentations.
Yes, madam.
This was our
All
last
presentation are done. Time for your closing remarks. I sincerely thank our authors for their excellent presentation in this session, and all our participants for being a part of the international conference. I hope this session was informative enough. All the presenters would be getting their digital certificate through email within 2 working days. Further, all the papers have already followed the Springer. The publication will be live within 5 to 6 months. Kindly cooperate with the team ICTIS 2022. I also thank our session chair, Professor Anba Jain, for chairing the session. Ma'am, this is a little token of appreciation on
Thank
behalf
you.
of Global Knowledge Research Foundation and ICTIS. Thank you for your valuable time, ma'am.
Thank you very much. I would like to end the session with congratulating all the participants for doing wonderful research in the field of computer science, and I wish them all the best in the future. Thank you very much.
Before we go, I want to ask all participants for turn on the camera for a quick snapshot for this virtual conference. So kindly please turn on your cameras. Thank you so much, ma'am. Be safe all.
Okay. Bye, everybody.